The electricity grid is the largest machine humanity has ever created. It operates on a supply-demand model, balancing supply with end load to maintain stability. When supply is insufficient, frequency and voltage drop, leading to brownouts or blackout situations the grid strives to avoid. The grid comprises a vast array of components, including generators powered by hydro, thermal, nuclear, gas, oil, coal, solar, wind, tidal, and other sources. Step-up transformers to increase generated voltages to transmission line levels. Long transmission lines. Step-down transformers substations to reduce voltages to local transmission levels. Street transformers to deliver consumer-level voltages 240 V, 110 V, and 400 V three-phase. Traditionally, the grid lacks the means to store electricity to match demand surges. Without battery energy storage systems Bess, any excess power must be dissipated. Generators must remain spinning, ready to connect when demand exceeds supply the spinning reserve. In a well-managed grid, this reserve can be 15 to 30% of capacity to handle demand surges. Bess addresses the supply-demand gap by storing excess power and delivering it when needed. Bess principal battery energy storage systems are becoming crucial in revolutionizing how we stabilize the grid, integrate renewables, and store and utilize electrical energy. Bess works by storing electrical energy in rechargeable reserves, which can later be discharged to meet local or grid-scale demand. Importantly, these battery reserves can quickly switch into grid supply when triggered by demand or frequency voltage instability. Many companies focuses on using Bess for behind-the-meter support and integration into and front-of-the-meter grid operations. This is relevant for both off-grid and on-grid applications, including local renewable integration at a site or providing power backup for unreliable grid connections. Although these storage systems require investment, they offer significant advantages. The primary benefit is their rapid response time. Battery reserves can typically switch to grid-synchronized AC within a few cycles of the AC frequency 50 to 60 Hz. The highest-priced electricity supply to the grid is fast response supply, making the commercial value of stored power 10 to 100 times the normal price. The right battery technology provides long-term stable reserves. Typical lithium-based batteries can maintain high power levels for years, if necessary, while flow batteries can hold power almost indefinitely. How Bess works: energy storage process and charger system. The process begins with the charger system, which takes excess AC grid or DC solar power and conditions it to recharge the cells. This can be done quickly or slowly, depending on the setup and available current. Enhancing microgrid efficiency, time shifting and integration. Bess can significantly improve local microgrid efficiency by time shifting lower cost power and smoothly integrating variable sources like solar and wind. This allows for nearly full utilization of their output through time shifting and buffering. Battery cells, energy storage. Energy is stored in battery cells, typically lithium-based, as electrochemical potential. This is supplied as DC potential difference, unlike the AC required by the grid. Cell construction. Cells can be cylindrical, prismatic, or pouch types.